Is we're going to learn how to add acceleration onto a motion diagram. And we know that acceleration is when the object speeds up or slows down. It can also change direction. And we want to make sure we add that onto our motion diagram, and I'm going to show you how to do that today. First, we're going to start with a little bit of review. You already know what speeding up motion diagrams look like. You see these arrows. These arrows represent velocity. This velocity gets bigger and bigger and bigger in the positive direction because the object speeds up. That's just review. Next, we have the curve down below. The second car, the velocities here are getting smaller and smaller and smaller because the object is slowing down. Remember that velocity tells you how fast it goes plus direction. However, there's one thing that we do have to still add on, and that is if there's acceleration, then we've got one more piece to add on to our motion diagram. As you can see from this example, we have an initial velocity 1 and then a next velocity 2. And you can clearly tell in this case it's speeding up. Well, what I'm going to do is I'm just going to show you how much it's speeding up by. So I'm going to take that initial velocity 1 and I'm just simply putting it down below. So we end up with a gap. This gap right here is how much the velocity has changed per unit time. And that is the acceleration. So the acceleration is telling me that it got bigger, the velocity got bigger by that much in that unit time. So if you think back to the car and ramp lab, many of your cars had an acceleration of 300 centimeters per second. So that means in that time interval, in that 1 second time interval, then that velocity changed by 300 centimeters per second. And it did that each time. Now, how does this look on a motion diagram? It looks like this. We have our initial velocity coming in. We have our next velocity. And the way that you show the acceleration is you put the acceleration arrow over the top of the dot. So now we have an additional arrow. We put it over the top of the dot because that is the point at which the acceleration happens. At that time interval is when my piece of equipment detected I went from this initial velocity to that initial velocity, and the acceleration occurs at that time interval. Now, let's take a look at another example, and this is one where it actually will slow down. We come in with an initial velocity that's larger than the second velocity. So I'm going to do the same thing. I'm going to show you that, all right, I had an initial velocity that was big, and I just put it down below, and we have this big gap right here. This gap right here now tells me that this time my second velocity got smaller. Okay, it got smaller. So in this case, it got smaller by that much, and now it's back to where it was. Now, if you notice, that means that I'm slowing down, so the acceleration is actually, in this case, going to be headed the opposite direction. So again, this is how we show it. We come in with an initial velocity 1. We have an initial velocity 2 that is smaller than initial velocity 1. So that tells me my acceleration is going to be headed in the opposite direction because my velocity got smaller than what I started with. Now, the way you show this on a motion diagram is exactly like what you see in front of you. If you notice, I don't put V's and A's, right? It's just the arrows and only the arrows, and I can go through and come up with a pattern. Now, I'm going to show you 4 scenarios, and I want you to see if you can figure out what the pattern is regarding the direction of the velocity and the direction of the acceleration and whether or not the object speeds up or slows down. So in this case, we can tell clearly that I have a positive velocity because my blue, my bottom arrows down here are going in a positive direction. I can also tell that I'm speeding up because clearly they get bigger and bigger and bigger. The other thing I can notice by looking at it is that I also have a positive acceleration. Now, the reason I know it's a positive acceleration is I simply just look at the size of it. Now, you'll notice the size of all those acceleration arrows are exactly the same size, and so what that tells me is that I have a constant acceleration. Now, do I have a constant velocity? No, my velocity arrows are definitely changing. Okay? Now, if we look at this, I have a positive velocity, a positive acceleration, and it speeds up. And very quickly, I could just sketch what the matching xt graph would look like. We've seen that graph a whole lot. very quickly, I could match what the VT graph would look like. Okay, now here we have the complete picture. We have motion diagram xt, vt. We know that we have a positive acceleration because the arrows are pointing in the positive direction, but we also know we have a positive acceleration because the slope on the vt is positive. Okay, so all things say the same thing. And once again, you're looking for a pattern on the direction of the velocity, the direction of the acceleration, and how the object moves. This example, take a look. Direction of the velocity in this case, again, is a positive velocity. And I know that it is slowing down, just simply by looking at it. And I know that my acceleration is a negative acceleration. I know it's a negative acceleration because I just simply look at the arrows. Again, what's the pattern? All right, so I've got another one here. I've got a bike. This time I have an xi out here at 10. And my velocity is a negative velocity in this case because it's going in the negative direction. I know that in this case my object is slowing down because my velocity arrows get smaller and smaller and smaller. And I can also tell that I have a positive acceleration. Positive acceleration is all I'm doing is looking at the arrows. That's all. Now if I were going to sketch the matching xt, my matching xt would look like this, and my matching vt would be on the bottom half because it's a negative direction, and it would be getting closer and closer and closer to that middle line, which represents zero velocity. So again, this shows me I have a positive acceleration on my graph as well. So I have a positive acceleration, I have a negative velocity, and it slows down. Last one I want to show you. I've got it on an incline. If you notice, I called down the ramp the negative direction. I can always define my positive and negative directions. As long as I define it, it's pretty clear. So in this case, I have a negative velocity, and my object speeds up. And if you'll notice, I have a negative acceleration. Now, if we go through and think about what the patterns that you see about the direction of the velocity and the direction of the acceleration and whether or not it speeds up, I want you to think about what the pattern is and write it on your sheet. What pattern are you noticing about the direction of the velocity and the direction of the acceleration when looking at whether an object speeds up or slows down?